Here we are again with some more calculator work. I'm back to that same screen again, but I'm just gonna do that reset, master reset. Let's all do it together. Second plus 7, 1, 2. So we're all at the same screen here. And to find our y-intercept, let's see, let's make up an equation here that we wouldn't know naturally looking at what the y-intercept would necessarily be. Let's do that. Plus 12. So we'll put that in. So we'll go to our y equals. We'll hit negative 4 x minus, kind of a funky minus sign, squared, plus 12. And we'll hit graph and take a look at what it looks like. And we can see here that we can't see our x or our y-intercept, but we know it exists somewhere down here. Well, the calculator has this really awesome trace key, and the trace key will allow you to trace any coordinate point on your graph or your equation. So for trace, we want to know our y-intercept, and we should know that our y-intercept is always going to be the coordinate point 0, something. We have to find out what that is. So to do that, if we hit trace here, it's giving us the coordinate point, and I could enter 0, and I'll just I'll put that in there like 0, and then it gives you, there is your ordered pair, so 0, negative 24. Say I wanted to know what the value for 1 is, I would hit 1, enter, and 1, negative 4, 2, and then let me find any value here on our graph. All right, roots. Roots are also known as our zeros or x-intercepts. So if we're looking here at our graph, it's pretty easy for us to, we can just pull this over here really quick. Pretty easy for us to see what the x-intercepts actually are. We know that we have 2 x-intercepts, although sometimes we'll have less than 2, but we have one here and one here, and it doesn't look like they're falling quite on an exact coordinate point. So there is a way to calculate that. Like I said up before, up here is kind of where you do all the calculations for your graph. So we're going to go back to second trace. So I'll start writing these keystrokes down. Second trace. And if we look at our options here, number 2, we're going to look at number 2, which is our 0. And we're going to kind of follow the same process as before. So the calculator needs to know which 0 we need to find, because it will only do 1 at a time. So I'm going to move my cursor, and this is the first 0 or x-intercept. So let's type in move cursor to intercept. And now it's asking left bound again. Sorry that you guys can hear everybody in the background. So left bound, we are going to move 2 spots over to the left. So move cursor to the left, 1, 2. So just like we did before. So we'll just do 2 times. And now we hit enter. And now it's asking for right bound, but before we do that, using your right arrow key, move back over. And then for right bound, once we've moved over, we move our right 1, 2. We move to the right 2 times again and hit enter. And the guess, you hit enter. So guess is enter, and there is our 0. So we would write this as a coordinate point. 1 point, I'm going to round to our hundredths or 2 decimal places, 27, 0. So if I just go through those strokes again with you, we hit second trace, number 2, which is our zeros. We move our cursor to the intercept, and then on the left bound, we click on the left arrow key 2 times and hit enter. Then we go back to our intercept, For the right bound, we move to the right 2 times and press enter, and then on guess we press enter. So those are the keystrokes that you need to get to your first one. So why don't you guys go ahead, go through this whole thing to find our other 0 or other x-intercept. We just found this one right here. We need to find the other one, and I'll quickly run through it and let's see if we come up with the same one. Okay, so you should be pressing pause right now, not watching me. Did you get 4.73, 0? Nice. Okay, so domain, we want to remember it's all of our x values. Now, we know that for our quadratics, it was always x as an element of all real numbers. We're going to get to some interesting things today where our domain is not necessarily going to be set by all real numbers. More likely than not, our domain is kind of going to be set by our x-intercepts, possibly our y-intercept. So we'll have to pay attention to the problem that we're actually computing. These might change now, so it might make it for a little more interesting. And then range has always been whatever, depending on if it's concave down or concave up, it's been y values going down or y values going up. And we're going to have to really pay attention now because our vertex will help us, but it won't be the only restriction. So will not be the only restriction. Only restriction. So we'll have to pay attention with that there. I'm going to press pause now before we go on to the next word problem.